Hello grade 10. Welcome to my channel Chemistry by Miss Nidhi Banga. Today we will be talking about soaps and detergents. We will be talking about cleansing of action of soap, emulsification, hard water, soft water, and differences between soaps and water. Along with that, we will be talking about all the activities in this topic, and then we will also be talking about the most commonly asked questions in boards. So let's get started. Okay, so let's first talk about what is a soap molecule chemically. A soap molecule is a sodium or potassium salt of long chain carboxylic acid. That is the very definition of soap. It looks something like this. Okay, this is the long chain and this is the carboxylic acid part. This is the sodium part. Here instead of sodium you can also have potassium. So this soap molecule has two parts basically broadly. One is this long chain. This is the hydrocarbon part. Hydrocarbon part. Hydrocarbon, that means it has only carbon and hydrogens. Here you would have CH3, then here you would have CH2, then again CH2, CH2. And like this it goes on, right? This hydrocarbon part is called as hydrophobic. Now this hydro means water. So this part is hydrophobic. That means it hates water. Hates water. Does not interact with water. This doesn't interact with water. Okay, this is the hydrophobic part, which is mainly hydrocarbon all along, and this is something that does not interact with water. It avoids water at all costs. Next up, here we have ionic part. You can see that this is the anion and this is the cation. When we add soap molecule in water, these two separate and only this remains, right? Still, it has a negative charge. It is the ionic part. Water loving part. We call it hydrophilic. Okay, this part would interact with water, whereas this part would want to avoid water at all costs. Okay, now let's talk about cleansing action of soap. In cleansing action of soap, like I said, that when we add soap into the water, the sodium and the carboxylate ion, they separate. Only the carboxylate ion remains with rest of the hydrophobic tail. So now, as I said, it would want to avoid water as much as possible, the hydrocarbon part. So this hydrocarbon part, this hydrophobic part, would remain at the surface of water as much as possible. But there would come a time where the concentration of soap is so much that it has to get inside the water. Some of it would still remain on the surface, but some of it would have to get inside. And when inside the water, it would want to avoid water. It can do so by forming clusters where all the hydrophobic parts are in touch with each other, but not the water. And these purple dots are the ionic part, the hydrophilic part. They are the ones interacting with water. But hydrophobic part, it stays inside the cluster, in the interior of cluster. Apart from that, what else can it do? It can also interact with something else which is also hydrophobic. So if there's a fabric which has oil and grease or dirt on it, That is hydrophobic. That is why it doesn't just go off by washing with just water. Soap has to be added, right? So this is hydrophobic dirt, oily dirt or hydrophobic dirt. So hydrophobic dirt can interact with hydrophobic tail of the soap molecule. They interact and it sort of latches, all the soap molecules sort of latch them around the oily dirt. And again, the ionic part, the hydrophilic part, is on the outside of this cluster interacting with water. Now, when you are washing clothes, you have to agitate the mixture either by either in the washing machine or by hand or by sometimes brushing. Okay, this agitation is necessary because this agitation would pull this thing off of the fabric. Okay, and it would make a structure like this. It's also a missile, but with the oily dirt inside in the center of the missile. This is also a missile. Okay, even though it doesn't have the oily dirt inside it, it is still a spherical structure where the hydrophobic part is on the interior of the structure and hydrophilic part is on the exterior. Right? Now that this oily dirt has been pulled off from the fabric and it's on the inside of the cluster, it can easily be washed away. And these two will not cluster together, would not come together, because you see the ionic part, if you remember, it sees COO negative charge. So there's a negative charge all around the missile. Same here. And if they try to come together, they would obviously repel each other. So coming together also is not an option. Okay, so these missiles, they are then rinsed off with water. Okay, so this is the cleansing action of soap. Next up we have emulsification. Okay, there's a question that says that cleansing action of soap is formation of micelles and also emulsification. Explain. So emulsification is also your activity 4.10. Okay, so in that activity what's happening is you have taken two test tubes or two beakers with water, and then there is oil on the top. Oil we know is lighter than water, so it's going to float. Okay, the difference there is that in the B beaker we add soap and then we give them, A and B, both a good shake. So what we would notice in A is that the oil layer would break into tiny droplets, right? But within seconds, like within a fraction of a second, they would coalesce together, they would combine together and will form the layer again. Okay, so oil and water would still be separated. But if you have added soap, what would happen is now the soap will emulsify the mixture. Emulsify the mixture means the oil droplets would still be formed, but they would not be able to coalesce or come together. They would not form the layer again. They would remain suspended throughout the water. Okay, so what happens here is that if you take a closer look at the oil droplet, it's not just oil droplet, it's a missile again. Here also soap molecules have surrounded the oil droplet, okay, in such a way that the hydrophobic part is interacting with the soap and the hydrophilic part, that is the COO negative, is on the outside of the missile. And obviously, since this also has negative charge on the outside, this also has negative charge on the outside, they are not going to come together. They are going to repel each other. So they will remain suspended in this thing. Okay, so this is how soap helps in the emulsification. Now, Colloidal nature of soap solution. Colloidal nature can be explained that the missile is actually falls in the size of colloidal range. If you remember grade 9, in grade 9 you learned about true solutions, colloids and suspensions. There you got to the first difference between the three was that they have different sizes of particles. True solution had the smallest size and suspension had the largest size. Colloid's size was somewhere in between. So the missiles, they fall in the colloidal range. The size of the missile falls in the colloidal range. And why soap solution appears cloudy is that the reason is that the missiles, the size is big enough to scatter the light. That is why the colloidal solution of soap in water appears cloudy. All right. So in this part, we have seen what soaps are, the chemical nature of soap, cleansing action of soap, emulsification, and now let's see some of the past year questions. I've not written the whole questions, but the essence. So very commonly asked question is very obvious. Explain the cleansing action of water. It can be a long answer type question where you have to explain this, what I just explained, with the help of a diagram. Okay, better illustrate this explanation. Then, why agitation is necessary? This is also an in-text question of your NCERT. Agitation is necessary to pull off the missile from the fabric, right? So that it can be then rinsed from the fabric, rinsed away from the fabric. Explain the structure of soap molecule. Here you would explain this thing, okay? And soap missile, here you would explain the cluster that it forms with hydrophobic part inside and hydrophilic part outside. So these are the most commonly asked questions from this topic. Next, we will be talking about hard water and soft water. Okay, now let's talk about hard water and soft water. For that, let's begin with activity number 4.11. So here in this activity, we have taken two test tubes. We have taken same amount of water in both test tubes, just that the water is not same. One is rainwater, the other one is tube well water. After that, we have added soap in both test tubes. Equal amount of soap, mind you, same type of soap and equal amount of soap. And after that, we shook them, these test tubes, equal number of times. Okay, so let's say 10 times we shook them both. Then obviously lather would be produced. But there is a difference in the length of the column of lather formed. In case of rainwater test tube, the lather formed is more as compared to the test tube which had tube well water. Why is that? The difference is that the tube well water is called as hard water. It's hard to produce lather with this water. And the rainwater is called as soft water. It's easy to produce lather with this water. Okay, so now let's talk about the definition of hard water and hardness and all that. So, hard water is the water that does not produce lather with soap. Okay, and if you were to define the hardness, then you would say it's the inability of water to produce lather with soap. What is it because of? It's because of the presence of chlorides, sulfates, and hydrogen carbonates of calcium and magnesium ions. What happens is when your when your groundwater or river water, these kind of water, they generally pass through some sort of rock formations. and while passing they leach out some of the salts, these calcium, magnesium, chloride, sulfates and hydrogen carbonates. They sort of leach out from the rock formations into the water. Okay, so there are more minerals in these kind of water. But why is that a problem? It's a problem because you remember the soap molecules. Here you have a hydrocarbon part and this is the ionic part. In the ionic part there was sodium ions or potassium ions, any one of them. Now what happens is when you dissolve soap in water, the sodium and the rest of the soap molecules separate. And if the water has calcium or magnesium ions, it's going to bond with the soap molecules. Now there is 2 plus charge here, -1 here. So calcium 2 plus will bond with 2 of the soap molecules. And after bonding, what is formed is insoluble in water. Okay, this is insoluble in water. It's called as scum or curdy white solid. So what has happened here? Your soap has formed insoluble precipitate with something, with the calcium ions in the hard water. Now this insoluble scum that has formed has used some of the soap. So whatever amount of soap you are putting in hard water, a good amount of that soap is being used to form scum, which is not of any use, right? So soap is wasted. Soap is wasted in hard water. So your soap is not very efficient when it comes to washing clothes in hard water. Okay, lot more soap, amount of soap would be required to wash clothes in hard water as compared to in soft water. Okay, now let's check the other activity. Here we have activity 4.12. Now in this activity we have taken again same amount of water, but this time the water quality is same. It's both hard water. Okay, but this time we have added different things into it. In one case we have added soap, and in this case we have added detergent. And then we did the same procedure. We shook the both test tubes equal number of times. Now, in case of soap, the lather produced is less. In case of detergent, the lather produced is more. Why is that? Why is detergent able to form lather with hard water? The reason is that chemical nature of detergent is not same as that of soap. Detergents are ammonium or sulfonates. Sulfonate salts of long chain carboxylic acid. Okay, so there is long chain carboxylic acid in both soap and detergent, but the ionic part differs. There it was sodium or potassium salt, here it's ammonium or sulfonate salts. So since chemical nature is different, its action would be different. It would not form scum with calcium or magnesium ions. So basically hard water would have no effect in this when detergent is used. So next is difference between soap and detergents, and you can write 4 differences or even 5 in case of soaps and detergents. The first one would obviously be the definition, which I have already mentioned. The definition you can write. These are the sodium and potassium salts of long chain carboxylic acid. These are ammonium and sulfonate salts of long chain carboxylic acids. Then these are not suitable for washing in hard water. Here they can be used for washing in hard water. Next, soaps have weak cleansing action. Detergents have stronger cleansing action. But there's a disadvantage as well. Soaps are biodegradable. Detergents are non-biodegradable. Now, the next point is fairly obvious. This soap does not cause water pollution, because all runoffs eventually lead to or eventually mix with the nearby water bodies. So soaps, since they are biodegradable, they would not cause water pollution, whereas detergents will cause water pollution. Now, if you were to write advantages and disadvantages of soap and detergents, there also you can use these points for the same. For example, advantage of detergent over soap, that it has a stronger cleansing action and it can be used for washing in hard water. Disadvantage, it's non-biodegradable and it causes water pollution. Now, there's one more question. Would you be able to check if the water is hard using a detergent? We know that detergent produces lather with both soft water and hard water. So if we had 2 test tubes filled with soft water and hard water, and if we add equal amount of detergent into it, they both will give same amount of water, same amount of lather. Okay, so detergents cannot be used to check whether the water is hard or soft. On the other hand, soaps can be used because soap would produce lather with soft water and not produce lather with hard water. What kind of water are soft water? Soft water is rainwater is soft. Then we have treated water, the water that you get in your house, that is soft water because it's been treated. Whereas groundwater, river water, tube well water, they all are hard waters. I hope this helped. And if you have any other query, any other question, any other topic you want me to take up, please let me know in the comments. And please subscribe, like and share if you like the video. Thank you.